Hello, everyone. Welcome to Homework Help for this week. Now, this might be something I do every week. I don't know. It really depends on the nature of the homework that we have or the learning activities that we have within the module. But what I thought I would do for this week is kind of do a little walkthrough of some of the problems, well, the three problems that we have, and maybe give some hints or some directional ideas as to where to go with that. So let's give this a try and see if this works. Hopefully, you'll have some benefit in doing this. But let me also tell you a couple of things about the homework. To be successful on it, of course, you got to read the textbook. I do know the textbook can be very dense. There's a lot of material. Sometimes they pack into only a few pages. You may have to reread a paragraph twice to kind of get the all that information out of it. So I do know that that can be a kind of an issue that you deal with as you're going through that textbook. But you do got to read the textbook. Usually, you can kind of correlate the questions with things that have been presented within that chapter, so that can help. Also, make sure you go back and watch the videos that I make for you. I do have them titled, so hopefully you can kind of match them up maybe with the type of homework that you're doing, and they may also help as well. So, and then we'll add a third component onto it, which will be homework help, this weekly edition. Maybe every week, maybe not. Again, I don't know. We'll see as we go. But this week's homework is a little bit maybe on the challenging side for some because it is math based, problem based, and we're dealing with concepts that you've never seen before, probably in your life. So you're kind of learning new language. The language of finance. So, all right, so let's take a look at our first question on homework help. And I will remove my picture off of here as I always do. So we've got question one, or number 10.1. Consider the following probability distribution of returns estimated for a proposed project that involves a new ultrasound machine. So you've got these states of the economy. This should look familiar. We've used similar language in the lecture and in the book. We've got the probability of occurrence and we've got the rate of return. So hopefully this little chart looks familiar. If it doesn't, go back and watch the videos and make sure you are reading the chapter. Now, our first question is, what is the expected rate of return on this project? Well, you guys know how to do that. We did a walkthrough on expected rate of return. And just as a kind of a flashback, let me bring it in here. Remember this, we did expected rate of return and we went and calculated that. Remember that the expected rate of return is really not that difficult. It's just a little, I guess, laborious because you have to do multiplications a bunch of times, maybe 5 or 6 times, and then you have to add everything up together. But you are taking the probability of the event, in this case it's the economy, and then the return associated with that, and you're simply multiplying that. You'll come up with an answer. And then you go to the next one. You do that, you come up with an answer. And after you do all of those, then you just simply add them all up, and that will get your expected rate of return. Again, you can go back to the video and watch me do a complete walkthrough on that. But there are all your probabilities. There's your rate of return. I think you got that one handled. It shouldn't be too difficult to do that. Again, only involving a simple calculator. All right, let's go on to number B. Now we're kind of ratcheting it up a little bit. What is the project's standard deviation of returns? And what is the project's coefficient of variation, the CV of returns? Okay, so we're throwing something new at you, which really isn't going into any depth in the chapter. But it's don't overthink it. It's pretty easy because right here the hint tells you what to do. CV is defined as the standard deviation of returns divided by the expected rate of return. Well, you've already calculated the expected rate of return in number A, so you keep that in mind. But you need to get that standard deviation. So let's take a quick look and recall our standard deviation skill. Let me bring that back in again. That we did go through in the lectures, but if you remember this formula here, it's not that it looks intimidating, but remember, it wasn't that hard. It was just a lot of what I say plug and chug. You got to plug the things in and then just follow the sequence, and then you're absolutely fine. But remember uh, I guess remember this step. It's a standard deviation is a two-step process. You got to find this variance first. That's kind of the hard part, getting the variance. So let's go over that real quick. So the variance is simply that probability of event one times the product of what's going to happen in here, which you're simply taking the return minus the expected rate of return that you've already calculated in B or in A. You've already calculated that expected rate of return, and then you're going to square that, what you get with this product right here, and you're going to multiply that times the probability, and you're going to do each one of those individually. Then you're going to add them all up, and that's going to get you the variance. Once you have variance, then you're going to just hit the square root button, and ta-da, you'll have your sigma, you'll have your standard deviation. So let's go back and look real quickly here. So again, you have calculated, let's see here. Well, we've already calculated our expected rate of return, and you're simply going to take that expected rate of return minus, again, this was the example that we did in the lecture, so you can always go through that. The expected rate of return minus these returns, whatever it is, for the given probability of occurrences. Let's say, for example, I'll pick on this one because it's easy. 10 minus 10 is 0. Squared is 0. Okay, so that gives you what would be in the brackets right down in this part of the problem. And then you just multiply that times the probability. In this case, it's 0 because 0 times something is 0. So again, go back and look at that. That should help you get the standard deviation on that, or get the variance. Once you have standard deviation, or once you have variance, it's super easy. Hit the square root button and you've got your standard deviation. And then we threw a little twist. We want you to calculate something called the coefficient variation. Again, just some simple division here. You're going to take that standard deviation and you're going to divide it by the expected rate of return, which is what you know. Then we have some thought questions. These aren't going to be math. These are going to be more definitions. So what type of risk do standard deviation and CV measure? But don't let that CV throw you. Just ask yourself, what risk does standard deviation measure? It was actually in some of our slides, and it is also in the textbook. So just focus on that. Then once you know what type of risk standard deviation is good for and measures, then that's what you're going to write here. In what situation is this risk relevant? And it's referring to whatever you found here for standard deviation. And again, you should find that pretty easily within the textbook, or even talked about in some of the lectures or in some of the lecture slides. I think I did correlate the two together, but again, it's in the textbook. So again, what type of risk is really good for standard deviation? Boom, you put that answer there. And then that risk is really good in what type of situation? Boom, you put that there. Again, you should find the answers pretty close together in the textbook. Okay, so that is homework help on number 10.1. All right, well, let's go ahead and continue on with 10.6 on this, and we're going to look at this question involving Apex Health Services. You've got these 4 different projects down here. You've got the amount invested for each of the products or projects right in this area. You've also got the corporate betas and the market betas pre-done for you for each one of the projects. So let's look at question A right down here. How do the corporate and market betas differ for the same project? So I'm sorry, why do the corporate and market betas differ for the same project? You don't have to do any math here. This is really asking you about the nature of the beta measurement. And I'll give you a hint here. The hint is, think of what is the beta measured with or relative to, and that should help you with the answer. Again, pretty clearly listed in the reading in chapter 10, so hopefully you can find that one. Let's move on to our next one down here. Hold on one second. All right, we'll look on to B. And bear with me here, guys. I'm using a brand new touch screen. Okay, so B, what is the overall corporate beta of the Apex Health Services? Is the beta calculated consistent with corporate risk theory? So let's really kind of have a two-parter here. So let's go back up and look at our numbers. We're going to need those numbers for this. So what you have to do is you're going to have to calculate this overall, that's the key, corporate beta. You've got all of the individual betas, right, for your projects. You know the amounts invested for each of the projects. I think you might be following me. Hopefully you are. You know the total amount. That's just all added up. This is a skill that you already have. Weighted average. That's all you need to do. Just do a weighted average for this. I'll work through the first one with you. Then you're on your own for the other ones and for coming up for the final answer. So, and excuse the formatting here. This is actually kind of a little skewed. These numbers really go up to each one of that. I should have brought that little column down. But we'll work on the first one. So the first thing I need to calculate is what is the overall percentage of the first one, the walk-in clinic. I got to calculate what percentage of that walk-in clinic is the overall of the total 5 million. And hopefully you know how to do some basic percentages here, but it's not too difficult if you don't know how to do it. You're simply going to take the 500,000 and you're going to divide that by the 5, I won't write all the zeros, but the 5 million. And when you do that, you're going to get a 0.10. What does that mean, Chris? 0.10. Remember, 0.10 is another way to write 10%. Okay? So now you know that the walk-in clinic is 10% of the overall. You also know what the corporate beta is. That's been given to us for that project, and it's 1.5. So all you're simply going to do is multiply that. So we have our 1 or our 0.10 times the beta for that project, the corporate beta for that project. I'm going to get a 0.15. And what you're going to do now is you're going to go through each one of these and just do that same procedure. And then you know how to do this. It's weighted average, and then you add them all up, and ta-da! You're going to be able to calculate your corporate beta. Just make sure you're using the right column on there. And remember, too, double check yourself. When you get all of your percentages, these decimal points right here, the 0.10 or the points, whatever it might be, it's all got a total 1 because 1 is 100%. So 1.00 is 100%. So make sure you've done your math right on that, and then you should be fine. Okay, so that should be pretty easy. The next question is, after you've calculated the corporate beta, so that's a math part of it, you're just going to have a number in there, and you're going to show your work. Is the calculated beta consistent with corporate risk theory? Well, I'm not going to help you too much on that one, but corporate risk theory is talked about, again, in the chapter, easily found in there. So if you've read the chapter, you're going to have corporate risk or corporate risk theory, and just speak to that with your beta in there. All right, so there we are. Not too bad, right? Look, the question looks kind of intimidating in the beginning, but it's really not too bad when you get into some of these questions. All right, let's move on to question C. What is the overall market beta? Okay, the market beta. Well, I'm not going to walk through this one with you guys because you've already calculated the overall corporate beta. Okay, I'll give you some hints. You've calculated the corporate beta. Now you're just doing the market beta of of the company. Okay, so you got the skills, you know how to do it. That one shouldn't be too hard either. Okay, this next question, question D, how does the riskiness of Apex stock compared with the riskiness of an average stock? Well, basically what we're doing is you're going to be comparing your corporate beta that you've calculated to that of the market. So you're going to have a number up here. You're going to know what is the beta. This is, and then you need to know this for the question, but it is in the reading. Of course, you could Google it and find it in a second. But what is the beta of the average stock market? You know, if you take the whole stock market in general, what is that beta? And you're going to really talk about the number you've gotten up here versus the number that you've received in comparison with the riskiness of an average stock, or really what that means is kind of the average stock market. Okay, so far, right, here we go. We're almost done with this one. Okay, so and again, just I guess let me talk a little bit, I guess the trick, if you will, that you have actually when you calculate C, okay, what is the overall market beta of Apex Health Services? And you're using that market beta column in here to calculate that. That the assumption is, and that where some students miss that, is that's where you're really calculating the beta of a theoretical Apex stock, okay? Because Apex is a company, right? And it would include all of those service lines. All of those service lines, you've been able to, you have the individual betas for those, both corporate and market, but you've been able to blend them all together and you've been able to weighted average them and to come up with an overall market beta for Apex. That's basically what the market beta for Apex, the stock, would be. Okay, so that's, I guess, the trick that if you didn't kind of catch that within D, that's the one that would kind of trip you up. But as long as you calculated this one up here correctly, you'll be able to speak to this one correctly. All right, let's move on to our last one on 10.6. This one is more of a theoretical, no math involved, just as in with D, there is no math involved, no math involved with E. Would stock investors require a rate of return on Apex that is greater or less than the same return on an average risk stock or the average stock market? Again, you're going to look at those two betas, and you're going to have to think if the beta that I calculated, maybe it's more or less than the beta of the market. And then if it's less, what would investors require? If it's more than the overall market, what would investors require? So this one is kind of one of these thought experiments. And even if you got the calculation wrong in here, as long as you understood how beta operates in comparison with an average, the average market, the average risk of a stock. Okay, they're going to use those terms back and forth. You'll be okay on the answer. So again, no math, but you have to know how beta is and how it operates and what it means in comparison to overall stock market. All right, so that concludes homework help on 10.6. Let's move on to our last problem. All right, let's move on to our last question, 10.8. And this one might be flipping you out a little bit as you look at it. But again, I think once we see it and go through it, I think you'll be fine with it. It's really not that difficult. And well, let's just jump right into this and see what we got here. Okay, so we've got Yahoo has given us these market betas. We've gone to Yahoo Finance and we have found these various market betas for these four healthcare stocks. So we're going to be using those. And our first question is, what are the required rates of return on the four stocks? And you're probably going, how do I figure that out? Well, from the chapter reading, I know that that section on the capital asset pricing model is pretty dense material, but you did run across something called the security market equation, or SML. We're going to use that equation to find it. And once you see how really easy it is, it's pretty powerful in what it can tell you. You can take a beta for anything and then calculate the required return for it. So that's pretty cool. So let's, at least for us finance people, that is some pretty powerful things. And that can have a lot of implications for you as a healthcare manager when you look at, what is the necessary required return for a particular endeavor if you know a beta. Or if you have all the other factors, you can solve for beta. It's an equation, right? So you can mix and match, and if you're really good with algebra, you can mix it all around. I'm not asking you to be really good with algebra on this equation. We're just going to take it for its face value. So let's start off with writing the security market line, or SML equation. It's going to be the required return. And I love how they write these. They write them so fancy that it really looks a little bit daunting. But when you actually break it down to its components, it's not that bad. Equals, so the required return equals the RF, which is risk-free rate. That'll be given to you in any problem that you receive on a test or what have you. And that's just basically the risk-free rate assumed within the general market. And do you guys remember, just a little aside here, what is considered a risk-free investment? Typically issued by a pretty big government where you live, U.S. government treasuries. Those are considered risk-free. Not in reality, I guess the U.S. economy could default on them, but it's about the best thing going in the world right now, which is keeping us afloat. So we have the risk-free rate plus the required return on the market, okay, which again, that'll be given to you, but that can also be calculated, or a quick kind of Google what the current standard is on that, minus the risk-free rate, okay, which you already know what that is, okay, and these guys are we're blocking these off in like a parentheses here because we got to do the order of operations. We got to do this first, this section first, and then we're going to multiply that times that beta that we were given. Okay, that's a beta, believe it or not. Okay, so let's plug and chug on our first one, and we'll get that for you, and then it's up to you to do the rest of them. All right, so we're going to use that United Healthcare Group. You see where I'm getting that from? We're going to use that beta of 0.7. And let's see what we got here. Oh, and the equation, or in the problem, we're given the risk-free rate, 2%. That's pretty good. And we're given the required market return of 8.5. So we just plug, okay? Risk-free we know is 2.0, okay, plus, I'll put my little brackets here. Our required market return rate was 8.5 minus risk-free again, okay, times the beta, which we said was 0.70. Run the math on this. 2.0 plus 6.5, and then multiplied times, or that's 7, that's a point right there, that beta that we had. Okay, order of operations requires that we do the multiplication first, so we're going to do that. Let me scoot this paper down a little bit. And when we get 6.5 times 0.7, we're going to equal 4.55. Okay, and we got the 2.0. That's a point right there. All right, I think you can do that, right? So 6.55%, or we can just say 6.6% is the required rate of return on this particular stock, that United Healthcare Group. Isn't that pretty cool? You can calculate a required rate of return, what that stock should be returning to you based on its comparative volatility with the rest of the portfolio, which in this case is the entire stock market. So that's a pretty powerful tool right there. All right, so you've got that. Now you're just going to have to go through and do the other three that are in the homework, and you should be golden on that. All we have left is B, and this is a pretty basic question. No math involved. I'm not going to help you too much on this one because hopefully you should know the answer on that or be able to talk about it. But again, no math is involved. But which of the stocks is the riskiest for investors? And explain your answer. So go back, kind of look at the four stocks that we have and talk about which one is riskiest and why. Hopefully that's a pretty easy conversation for you at this point. All right, well, that concludes the homework help. I hope that this has been beneficial for you, and know that this will be a weekly series for most homeworks, not all, but something that should help supplement your understanding of this week's material. And as always, thanks for watching.